So once again, the quiz tomorrow is going to be almost identical to the two worksheets you got. One worksheet is a review of 2.5, the other one's a review of 2.6. They're going to be very similar to it. I just change a value or two, so I want to discuss them. If you want the actual questions that might appear on the quiz, you got to go back to your other homework worksheets, WSP 2.5 and WSP 2.6. Anyhow, let's begin on this first part of the worksheet WSQR 2.5. We are evaluating variable expressions that involve absolute value. So the only variable on number one is b, and b happens to be -4. So we simply plug in a -4 right in there. Notice that I rewrote everything except for the b, which is -4. So I am going to plug in that -4 right in there. So the question is, remember on absolute values, you zoom in to what's inside the absolute value, and if you could do it, you do it. And right in there we have a -4 plus 1, and -4 plus 1 is -3. That's like owing 4 and having 1, you're going to owe 3. And you still have the absolute values around it. Now you still have the +8 that's over here at the end. The absolute value of -3 is +3. So what you really have is 3 plus 8, which gives you your final answer, which is 11. 3 plus 8 is 11. Moving on to number 2. Or perhaps let's do all the odd ones. Let's do the odd ones on this one, on this video, and then we'll do the even ones on the other video. So right here, let's jump to number 3. And the only variable that we have here is the z, and z is -2 in this case. So let's replace that z with the -2. I'm just going to rewrite everything exactly the way it is, but I'm going to leave a blank spot for z. So notice that the blank spot is right here, and I'm going to plug in a what? What's z? -2. So on the inside of the absolute values, remember absolute values are like parentheses. You zoom in and do whatever you can. And in here we have 2 times -2, which is -4. When I do this, I get -4. And then I have -4 plus 1 inside of the absolute value still. And the -4 plus 1 is what? -3. If you owe 4 and you have 1, you're going to owe 3 still. And it's still inside the absolute values. Did we have anything on the outside? Yeah, we did. We had the 16 minus on the outside. Let's bring that down so we don't forget about it. 16 minus. That 16 is ugly. Let me make it better. It's a plus? No, it's up here. It's a minus. Check it out. There's a minus right here. So 16 minus, 16 minus, 16 minus. Okay, so the absolute value of -3, absolutely, that does turn to a +3. You're right. Sorry, I didn't understand what you were saying. So yeah, the absolute value of -3 is +3. So what we really have is 16 take away +3. And 16 take away +3 is 13. And that is your answer for number 3. Let's jump to number 5. Number 5 says solve the absolute value equations. So solving absolute value equations requires us to think of both positive situation and negative situation. All right. So the positive situation is rewriting it exactly the way it is without the what? Rewriting it exactly the way it is without the what? Without those little lines, right? Oh, the lines, yeah. So what we really have here is c minus 4 equals 1. Now for the negative situation, it's the same thing. The only thing is that you change the sign of the right side. So everything else stays identical. C minus 4 equals change the sign of the right side. So put a negative on that one. So those are the difference between the positive situation and the negative situation. Both of them don't have these absolute value lines anymore. And the positive, you write it exactly the way it is. The negative, all you do is put a negative right in front of the right side of your equation. So let's solve the positive situation. I'm going to add 4 to get rid of the -4. Add 4, which do to one side, do to the other. You will have c equals 5, and that is one answer. The other answer, we're going to add 4 again. Add 4 again, but this time we have a -1 up here, which is different than the other situation. So right here, -1 plus 4, what do we get there? we get C equals positive 3. And that is, or those are your two answers for number 5. Now, of course, on any equation, if you wanted to double check your answer, all you have to do is plug in the number. If you plug in a 5 right here, 5 take away 4 is 1. The absolute value of 1 is 1. If I plug in 3 right there, 3 take away 4 is negative 1. The absolute value of negative 1 is also 1. So both of those answers work. Let's jump to number 7. Again, doing the odd ones on this video, I'll do the even ones on the other video. So again, on number 7, let's set up the positive and negative situation. And the positive situation, how do we write it? How do we write the positive situation? Exactly the same without the lines, right? So we have 2z minus 9 equals 3. And the negative situation, same exact thing, 2z minus 9, but instead of 3, what do I put? The negative 3. Again, guys, you have to do this on your own tomorrow, right? So pay attention right now, follow along right now, practice right now. Let's solve the positive situation by adding 9. Adding 9, we will have the 2z that comes down, the equal sign comes down, and 3 plus 9 is 12. Final step is to recognize that that really says 2 times a number z equals 12. You could even logically think that the answer z is 6 because 2 times 6 is 12. But let's actually show our work here. To get rid of the multiplication of 2, I divide by 2. And what I do to one side, I do to the other side to maintain the balance of the equality of the equation. So I really have z equals 6. That's one answer. The other answer, same thing, add 9 to get rid of that minus 9. What you do to one side, you must do to the other. You'll have 2z equaling negative 3 plus 9 is 6. And what we really have there is 2 times z equals 6. So the way to get rid of that multiplication of 2 in front of the z is to do the opposite, which is dividing by 2. Dividing by 2. What you do to one side, do to the other side to maintain the balance, to maintain equality. Final answer is z equals 3. So those are your two answers to number 7. Finally, the last two, fun stuff. In order to do 9 or 10, I want to go to the middle right here. You might want to do the same. You want to jot down these notes that are on the board. Yeah, I know it's kind of gross right there, but the setup is absolute value. Absolute value of x minus the midpoint equals distance from point to midpoint. Okay, that's a setup. So let's go over here and let's set it up. We're going to put absolute value of x minus midpoint. I'm going to leave a blank spot for the midpoint equals, and I'm going to leave a blank spot because the answer is the distance from the point to the midpoint. So again, right here's the midpoint, and over here's the distance from the point to the midpoint. So ladies and gentlemen, what would the midpoint be? What number do I put in here? What number do I put in there? 0. Yeah, what is the point that's perfectly in between these 2 points? The value of 0. So the midpoint will be 0. And how about right here? The number over here is the distance from the point to the midpoint. So what's the distance from the point to the midpoint? 1. So this is the answer, but of course the better looking absolute value equation, you don't need an x minus 0. You could just put absolute value of x equals 1. This is the best absolute value equation that you could write when it comes to this guy up here. Is this one wrong? No, it's all right. It's perfectly fine because that is the setup, right? The setup is absolute value of x minus the midpoint equals the distance from the point to the midpoint. Anyway, we did the odd ones on this worksheet WSQR 2.5. Let's jump to WSQR 2.6. Again, worksheet quiz review 2.6. Let's jump to that one. And again, we're going to be doing the odd ones on this one. And this one's all about cross multiplying. So on number 1, we are going to cross multiply. And of course, we have big numbers here. We need calculators. So do me a favor, somebody get a calculator ready because I'm going to need some help. Cross multiplying y times 9. You could write that y times 9, and then the equal sign comes down right between it, and we have 3 times 96. 3 times 96. So y times 9 is 9y, and 3 times 96?
288.
Thank you very much. So here's your new equation. No fractions involved. It's nice and beautiful. All you got to do is get rid of this multiplication of 9 by dividing by 9.
Y equals 32.
Thank you very much. 288, I don't know, but you told me, calculator, right? Y equals, head. Oh, you're a genius. Thank you. So number 1, y equals 32. Let's jump to number 3. Again, doing the odd ones on this video, we'll do the even ones on the other. Now, guys, let me give you a shortcut or some advice or a trick to make it easier. Anytime you have any math that involves fractions, and if you could reduce the fraction, it'll make it easier. So reduce it if possible, right? When we look at this fraction 3/12, what does it reduce down to? What does 3/12 reduce down to? 1/4, right? If you reduce by 3, it'll become 1. Reduce by 3, it'll become 4. So you really have a 1/4. Now that's a lot easier to cross multiply. 5 times 4 equals b times 1. So what you really have here is 20 equals b.
B equals 20.
Yeah, and that's your answer. Yeah, b equals 20. Switch it and you're done. B equals 20. So it's a lot easier to reduce first. It's better than, I mean, you don't have to reduce first, right? I'm just giving you some advice, a shortcut, a little easier work. You could have multiplied 5 times 12 and got 60, set it equal to 3 times b. But it's easier to reduce first and then multiply, and you'll be able to finish quicker and probably not make mistakes. So should we just start multiplying across, or should I reduce first right here? Reduce first is a better option. So check this out. I'm going to reduce. Now, you know what? Let me start with what you should always start with. If you have a binomial, if you have two terms in a numerator or denominator, please put that in parentheses. Everybody put parentheses right now around the y plus 9. That way, if you did decide to distribute 3 times this, you go 3 times y, 3 times 9, and then multiply 2 times 12, cross multiply. But if you wanted to reduce, it gets even easier. 3/12 reduces down to what? What does 3/12 reduce down to? 1/4, right? 3 divided by 3 is 1, 12 divided by 3 is 4, so 1/4. So when you cross multiply, it's ridiculously easy. It's 1 times this, let me write that down, 1 times parenthesis y plus 9 equals 4 times 2. So 4 times 2. So obviously it's super easy distributing a 1 because it's not going to change anything, right? Distributing 1 times y, that's just y. 1 times 9, that's just 9. Doesn't change anything. Equals 8. So what do I do next? Minus 9, subtract 9. Final answer is y equals -1. So it really is a lot easier to reduce first if possible. I mean, if you had a 3/11, you wouldn't be able to reduce. If you had a 3/7, you wouldn't be able to reduce. But 3/12, you could reduce that. You don't have to. If you would have multiplied 3 times a binomial equals 12 times 2, you'd still be able to solve it, and the answer would be exactly the same, -1. Let's jump to number 7. Here's another one that has a binomial in the numerator. So again, begin with those parentheses. Could I reduce on this one? No, can't. I cannot. 5/12, you can't reduce. Can't reduce by 2, can't reduce by 3, can't reduce by 5, can't reduce. All right, so we need to jump right into the cross multiplying. So let's set this up. 5 times 4, 5 times 4 equals 12 times 12 times that binomial x plus 2. Again, if you didn't put parentheses, you would forget the distribution that needs to happen and you'd get the wrong answer. So you need parentheses around that binomial. So what we have on the left side is 20 equals 12 times x is 12x. 12 times 2 is 24. Thank you. So now let's solve this thing. The x, is the x on the left side or the right side of the equal sign? Right side. Let's get it by itself. What do I get rid of on the right side? Subtract 24. Thank you. And when I subtract 24 to one side, I
That
must.
was a 2y.
Oh, I'm sorry. Yeah, it's 24. Sorry, handwriting I have here. So 20 take away 24 is what? Negative 4. And you could use the calculator, of course. Equals 12x. Final step to get x on the right side of the equal sign would be to divide by 12 to get rid of it. Divide by 12. And that's your answer, but that's an answer that's a fraction that could be reduced. So x equals negative 1/3. X equals negative 1/3. It's better with the x on the left and the number on the right. That's number 7. Let's move on to number 9. Number 9, the last 2 questions on the quiz will be old multi-step equations. We can't forget these old multi-step equations. So we need to simplify each side. So the question is, do you want to work on the left side or the right side? Left side first? Sure, why not? So we're going to distribute this 3. 3 times x is 3x. 3 times negative 8 is negative 24. And we're going to bring down that minus 5. So what we have here is 1, 2, 3 terms. Out of those 3 terms, which ones could I combine? Negative 24 and negative 5. Thank you, guys. What do I get when I combine those? Negative 29, right? You owe 24, you owe 5, you're going to owe 29. So we have 3x owing 29, and that's as much as you could simplify on the left side of the equal sign. So at this point, I mean, if you wanted to, you could cover it with something so you don't get confused. But the fact is, we're only going to work on this side. We're not going to work on the left side anymore because that's as simplified as it gets. Now, I don't really care of seeing my work there. Some of you might. I'm just going to show it. So on the right side, we're going to distribute as well. 9 times x is 9x. 9 times 2 is 18. And then we have this minus sign that we need to distribute as well. Minus 6x, that'll be a minus 6x. Put a minus in front of that minus 1. It'll be a minus minus 1, which really becomes plus 1. So now I have 1, 2, 3, 4 terms. And out of those 4 terms, I could combine the x's, the 9x, and the minus 6x. That's right. Now what is 9x? Yes, 3x. 9x minus 6x is 3x. And now how about the 18 plus 1?
Plus 17.
That's actually plus 19, right? Positive and positive stays positive. It's like having 18 and having one more, you have a total of 19. So let me rewrite my new equation. In other words, let me get the equal sign and put it right here. And let me rewrite the 3x plus 19. That way, it's all in red. It looks nice. Now all I need to worry about is getting x by itself on one side. I have x's on both sides of my equal sign. So let's get x's on one side by getting rid of this one on the right side. It'll get rid of it. But when I do it to the other side, it also gets rid of it. So we have no solution. There are no x's. And if you end up with something that's impossible, like negative 29 equals 19, that's impossible. So that's when you say no solution. Okay, now that might not happen on tomorrow's quiz. Maybe on tomorrow's quiz, you end up with a 19 right here equals 19. And if it's 19 equals 19, then it wouldn't be no solution. It would be infinitely many solutions. Or you could say x equals all real numbers, right? So keep that in mind. If it's always true, it's all real numbers, infinite solutions. But if it's never true, you say no solution. So I hope that's good enough practice. You guys saw all the odd ones explained. I would go back and do the even ones. If you already did all of them, that's great. I would go back and study the ones you kind of struggled with. But tomorrow's a quiz. And guys, if you haven't figured it out yet, the only way to get a passing grade in this class is to pass the quizzes and tests. There's really not much else. Your entire grade's pretty much from quizzes and tests. So please do that. Do the even ones. Check your answers. I'll post them on Edmodo. They're posted on the wall. And you should be ready for the quiz tomorrow.